So now we discuss the topic about CBEMA and ITI curves. What is meant by CBEMA means Computer and Business Equipment Manufacturers Association. Computer and Business Equipment Manufacturers Association. So this also gives the voltage levels, which is under voltages, which is the over voltages. So that gives exact curve. So this is a CBEMA and ITI curves. So please see the voltage levels. The voltage level lies in between 0 to 180 volts. So please observe that one. So the time period, timing cycles 0.1, 1, 10, 100, 1000, 10,000 and more timing cycles. The frequency is 60 hertz. This is a percentage of voltage, whatever the percentage of voltage. So if the time period is below one time period, below one time cycle, so here the start time is from voltage 0 to that rise up to 80 and then increases to 87 percentage, then increases to 87 percentage. So in this curve, in this region is operated in under voltage region. This 87 percentage region is a under voltage region. So in the similar manner, the voltage starts from 140 percentage to that will decreases and and that will comes into this period. So in this region, what is my indicator indicate this region is a over voltage in region. So below 87 percentage of voltage is a under voltage. Above 106 percentage of voltage is called over voltages. So the voltage must lies in between 87 percentage to 106 percentages only we consider is a good voltage or without disturbance voltage in a power system. So we consider only in between 87 percentage of voltage to 106 percentage of voltage curve only we consider is a disturbances less power or disturbances less voltages. So remaining regions are the disturbances region, which is harmful for our equipments, our electronic or electrical equipments. So this is a tolerance. The 87 to 106 percentage is a tolerance voltage. That is a limited voltage. We allow that one. So below 87 we not allowed that one. Above 106 percentage voltage we not allowed that one. That is very harmful. Please observe the CBEMA curve. So this region is a computer voltage tolerance envelope. So before 10 cycles, with the normal fluctuation in a voltage also we not consider that one. Before one cycle there is a more voltage fluctuation. The fluctuation lies in between 0 percentage of voltage to 140 percentage of voltage. We not consider, no need to consider. But the time period increases, the voltage must be come into stable condition. Stable condition means the voltage must lies in between 87 percentage to 106 percentage of voltage. A portion of CBEMA curve commonly used as a design target for equipment and format for corresponding power quality variation data. So basically the CBEMA curve was originally derived to describe the tolerance of mainframe computer business equipment to the magnitude and duration of voltage variation on the power system. Also, the association designed the curve to point out ways in which system reliability could be provided for electronic equipment. Please observe the voltage percentage of normal voltages lies in between 0 percentage to 300 percentage. So which is the prohibited zone? Below 87 percentage, above 106 percentage is a prohibited zone. So these are the permitted zone, which is the green. These are the permitted zone. So before 0.5 cycles, there is a lot of disturbances in a voltage. Also, that is a negligible. So the lot of fluctuation because of transients. That is lies in only in very few cycles. We neglect that one. That is not harmful to our electrical equipments. So the main intention of voltage that must be lies in between 87% of voltage to 106% of voltage. So ITI curve means Information Technology Industry Council, a set of curve published by the Information Technology Industry Council ITI, representing the withstanding capabilities of computers connected to 120 volts power system and in terms of the magnitude and duration of the voltage disturbance. The ITIC curves has been applied to general power quality evaluation. Even thought it was primarily developed for 120 volts computer equipment, just like the CBEMA curve. Also, it is used as reference to define the withstand capability of various loads and devices for protection from power quality problems. So this also is same. So prohibited zone, no damage region. So interruption, no interruption region. This one is 92 110. So the modification of CBEMA curve is a ITIC curve. So that's also a lies the voltage lies in between 90 to 110. That gives voltage 90% to 110% is a no damage region. So before in CBEMA curve, that is it lies in 87% to 106%. But in ITIC curves, the modification is the voltage must lies in between 90 to 110 volts, 90% of voltage to 110% of voltage. Please observe the curve carefully. So this is a voltage tolerance envelope applicable to single phase 120 volts equipments. So ITI is a revised curve or CBEMA curve, revised on 2000 year. So the enlarge of ITIC curve, the ITIC curve enlarge. Please observe this one, which is the permitted region, which is the damage region. Please observe that one. So responsibility of suppliers and users of electric powers, electric generation, transmission and distribution. How to transmit, how to generate the electric power by using thermal or hydel or nuclear. So that must be a transmit the voltage, because for reducing the losses that must be a distributed the voltages. Voltage, the distribution voltage levels is a 400 volts 3 phase or 11 kV 3 phase. So immunity and power quality indices. So high immunity description or high immunity equipment immunity indices are motors, transformers, incandescent lighting, heating loads, electromechanical relays. Moderate immunities are electronic ballast, solid state relays, programmable logic controller, adjustable speed drives. Low immunities are signal, communication and data processing equipment, electronic medical equipment. Power quality indices are low power quality problem, service entrance with switchboard, lighting power distribution panel. Moderate power quality problem are HVAC power panels. High power are panels supplying adjustable speed drives, elevators, large motors. Sources of poor power quality. So what are the sources of poor power quality? Sources of poor power quality are listed as follows: adjustable speed drives, switching power supplies, arc furnaces, electronic fluorescent lamps, lightning strikes, line to ground faults, non-linear loads, starting of large motors. These are the sources of power quality. This gives very that provides very, these are the more inductive loads. Inductive loads causes very disturbances in your power qualities. So power electronic devices also non-linear load, that causes also a harmonics. Thank you.